I'll show it. One minute. Just I will share the screen. Yes, that is network flow problems. That is CPM and PERT method. Unit 12. Okay. Let me start unit number 12. Well, in our final exam, we will get the one long answer question from this network flow problems. That is, in this we have two methods. One is CPM. CPM means critical path method, and another one is PERT, programming evaluation review technique. Okay. Yes. So here network analysis. So it is the one of the most important topic in operation research. That is, this is purely application oriented problems. In this, we are going to discuss application oriented problems. So here, whenever there is a some projects are there in in what way we have to complete that entire project within given period of time means. So we have to take the first planning, how we are going to plan, how we are going to complete that project into so and so duration time, how much we need money matter, and how much, what about requirements. We have to plan all this in step by step. So how much time you want to need, and what about amount, amount matter, and labor work, and different constraints. In what constraints we are considering to complete the given project within period of time. So all that comes under the this network analysis or network diagram. So in this, for solving the network analysis problems, we have majorly two methods. One is CPM, critical path method, and another one is PERT, programming evaluation review technique. Or else we can call this as a project evaluation review technique. So here in this first, let me discuss some terminology in this. In network analysis here, first we have some basic definition. Just I will share the screen. So, yes. So under this, first let me discuss few basic definitions and terminology in this. So first coming to the project. The meaning of the word project is a project defines a combination of interrelated activities which must be executed in a certain order before the entire task can be completed. Yes, I will repeat once again. The meaning of this word project. A project it defines a combination of interrelated activities which must be executed in a certain order before the entire task can be completed. Under this, we have two major definitions. One is activities and one is node. First, coming to the what is the meaning of activities? So, activities means the activities are interrelated in a logical sequences in such a way that same activities cannot start until some others are completed. Yes, see here I will show it with diagrams here. Meaning of this is here. So activity, activity and nodes, activities and nodes. I will explain this with a diagram. See here, let us suppose this is starting event. This circle is called event or node. Events or nodes. And if you connect these two nodes or two circles with one arrow mark, this is called activity. Activity, and these are the called node. Node are you can call it with events. Okay, or events. So A is the starting event and B is the ending event. So I am taking the direction like this. A to B. It is A to B. Starting event is A, ending event is B. So this is one network. So two circles or two nodes or two events are connected with one arrow mark. That is called activity. Okay. And these activities are divided into three types. One is predecessor, predecessor activity, and post activity. Predecessor activity means the activity that having before the activity. That is, here, if this is B is the activity, and from B, I am taking two more activities, C and D. Let us suppose like this. So for these B, the predecessor activities, so the activity before that activity comes. So here B is the first activity. Before B is we have activity A. That is, if you the names with this is let us suppose L M N. I am giving the names L M N. So L activity L means A to B. It is L. B to C it is M, and B to D it is N. So before Mn we have the activities L. So this L is the predecessor activity of M and N. Is it clear? So here the L is the predecessor activity for the activity M and activity N. Okay. So before M we have one L. That L is called predecessor activity, and post activity is so after completing L, we are going to start M and N. So these M comma N are the post activities for activity L. So these M and N are called post activities for L. Predecessor and post activity and yes. Ramaya Ramabhadraya Ramachandraya Vedase. One minute. Here. One minute. Here. So predecessor activity means an activity that must be completed immediately prior to the start of another activity are called predecessor activity. Like this. Just now I showed in the figure. So it means an activity that must be completed immediately prior to the start of the another activity are called predecessor activities. So simply predecessor activity means before that term or before that activity, is there any activities? That kind of activities are called predecessor activities. Next, successor activity. Successor activity means the activity that cannot be started until one or more of the other activities are completed. As I will repeat once again, activities that cannot be started until one or more of the other activities are completed, but immediately succeed them are called successor activities. Okay, successor means simply in one word we can say after that activity, the activity which can be completed, then whatever the activity we are going to come, that is known as successor activity. Okay, and I'll show in a figure. Yes, here. So this is here. See this figure. Is it clear? I'm taking 1, 2, 3 are the three events and A, B are the activities. So 1, 2, 2 I'm indicating with the activity A, 2, 2, 3 I'm indicating with the activity B. In these figures here, B is B is the successor activity of activity A, because after completing A, B will come. Is it clear? B is the successor activity to the activity A. Why? Because after completing A only, B will begin. So B is called successor activity. If you same in this example, A is called predecessor activity of B. Why? Because before B we have activity A. Because of that we are saying A is the predecessor activity of B. Similarly, see in this figure, I am taking four nodes, four circles, and 1 to 2 circle I am indicating with A, 2 to 3 B, 2 to 3 activity C. So in this here, so in this we can call it is a B and C are the successor activities of A. Why? Because B and C will begin after complete of A only. So that's why I'm calling B and C are the successor activities. Similarly, A is the predecessor activity of B. Why? Because before B we have A. Similarly, A is the predecessor activity of C because before C activity we have activity A. So like this we can define that these two definitions: predecessor activity and successor activities. Okay. Next we have some more definitions. There that is uh, merging or merging the burst and merge events. Before that, I will show the events definition here. Next, event definition. As an event represents a point in time signifying the completion of the same activities and the beginning of new ones. So, event means it is simply you can say a circle. That is, an event represents a point in the signifying completion of same activities and the beginning of new ones. This is usually represented with circle or in a network diagram, and it is also called connector or node. So node or connector or event indicates same. The event indicates with a circle. It is denoted with circles, and here also we have uh, three types of events. That is merge events, burst event, merge and burst event. I will show with the figure here. So events are connectors. Simply we can say connectors, or it is denoted with circles. And events are defined in three types. One is merge event, another one is burst event, and merge and burst events. I will explain this with diagrams here. If we take same in this example, in this here, okay, let us take example like this. Yes, this is event A, event B, and these two are merging at event C. So this is in this here, C is the merge event. Why? Because two events are merging at one another event. This is called merge event. Okay. So this is the merge event. If it is same this like this, I am taking event A here. From A to I am distributing some more events. This is with called with name C. This is name, sir. This is B and this is C. So here B and C are the or A is the burst event. From A, it is distributed or it is separated into two different events. So that's why I'm calling A as a merge. A is called burst event. Burst event. Okay. So here two different events are clubbing at C or merging at C. So we are calling C as the merge event. And here from A from A it is two different events are spreading. So that's why I'm calling it is a burst events. B and C are the two different burst events. And if you club these two, we'll get merge and burst events. Merge and burst events. That is two events are merging in with another event called this is A, B, C. From C onwards, again it is distributing three different like this. This is D, E, F. So in this, if you go in this direction, we are calling C is the merge event. Why? Because A, B are merging at C. And if you move from C2 like this, here C is called burst event because C is separating with three different events D, E, F. So this is called merge and burst events. This is only burst event. This is merge events. So these are the different types in events. Next. Next, coming to the basic here, basic steps which are involved in PERT and CPM. Okay, basic steps which are involved in PERT and CPM. So for solving PERT problems and CPM problems, we have to follow these following steps. One is, so the project scheduling by PERT and CPM contains four main steps. First one is planning. So we have to take the plan. What is our plan to complete that entire task or entire project? Then scheduling. So what type of schedule we are going to make for finishing that entire program? Next, allocation of resources. What kind of allocation, what type of resources we have? With the help of that resources, how we are going to finish that entire work, and controlling. So finally, this phase in project management to achieve the designed objectives or desired objectives, whatever the objectives we require, we have to fulfill or we have to finish with these controlling quantity. So these are the four basic steps which are involved in solving PERT and CPM techniques. One is planning, one is scheduling, one is allocation of resources, and controlling. Next. Here, next. Next, network diagram represents, as already we finished this, activities. Activities means it is a connector, and activities is divided into two types. One is predecessor and successor. And here we have two more activities, that is concurrent activity, dummy activity. Dummy activity means if there is no any route map in between two nodes or two events, in between the two, we are introducing one dummy activity or one dummy route. That kind of activity is known as dummy activity. And see here, if it is concurrent activity means activity which can be accomplished concurrently are known as concurrent activity. So there is no any meaning of this, but it can be activities which can be accomplished. It can be accomplished concurrently are known as concurrent activity. It may be noted that an activity can be predecessor or successor, any one of predecessor successor to an event, or it may be concurrent with one or more of the other activities. I'll show this in a figure. See here in this figure. So, so I'm taking total here one, two, three, four, five, five nodes, and among that five nodes, I'm taking the one to two events. I'm connecting with activity A, and 2 to 3 activity C, and 2 to 4 activity B, and 4 to 5 activity D. Actually 3 to 4 there is no any activity. So I want to make one route map from 3 to 4. I'm indicating with a one dummy activity here with the dot lines. This is called dummy activity. Actually there is no any route map from 3 to 4. In between that 3 to 4, I'm introducing one dummy route with the dot lines, that is dummy activity. And uh, dummy activities in second bit also here. In second example also. 5 to 7, we have one route map. 5 to 6, we have one route map. But 6 to 7, there is no any route map. So in between that, I am introducing one dummy activity. Okay. These are the dummy activities. Next. One minute. Here. Next. Basic scheduling components. So coming to the basic scheduling components here. Uh, we use the following notations. So while solving the PERT CPM problems, we are going to use these notations. Yes, the combination of ij. The activity ij means it indicates activity ij with tail event I and head event j. So I indicates tail event and j indicates. One minute. These are the notations. Here, while going to solve the a network problem with by using a PERT and CPM method, we have to take these basic notations. So IJ, the pair of IJ indicates, the I indicates activity with tail event I, and J with the head event. Okay, I indicates tail event and J indicates head event. And T suffix E or EJ, it indicates earliest time, concurrent time of event I. And TL or LJ, latest allowed occurrence time. So this is, I will show it. So here, suppose this is, I'm taking the figure like this. This is activity. Let us suppose this is event 1, event 2, and this is activity A. And here, if you take one rectangular box here, and this indicates, so this indicates in forward direction. In forward direction, this is called AEST, means it is earliest starting time. And if you go second event and indicate one rectangular box, this indicates EST, earliest starting time of event 2. This is earliest starting time of event 1. And if you come in a backward direction, okay, so this is LST, latest starting time. This is LST. So for each and every individual event, if you go in forward direction, this is EST, earliest starting time. This is earliest finishing time, EST, EFT. Some of the textbooks simply is giving this is EI and EJ. EI indicates earliest starting time. EJ indicates earliest finishing time. These are the notation in forward direction only. Similarly, if we take in backward direction, if you take one node or one circle and indicate the time values like this, this is, if you go backward direction, this is latest starting time called with LI. This is LST, this is LFT, means latest finishing time, LJ. So for event, this is the latest starting time. This is, for this event, this is latest finishing time. Okay. Suppose here, I'll show it here. One diagram is here like this. A, this is, let us suppose the figure is like this. So here I'm taking, this is 1, 2, 3, 4, 5, 6, and so on. So in this network or in this diagram, 1 is the starting event and 7 is the ending event. So from here to here, I want to move. So how many routes we have? Yes, this is 1 to 2, 2 to 3, no, 2 to 4, 4 to 6, 6 to 7. And another route we have 1 to 3, 3 to 5, 5 to 7. These are the two different route maps. So in this here, if you go in forward direction, if you go in forward direction, for this event 1, for this event 1, this is the earliest starting time. And this is earliest finishing time. This is EST, EFT. And this shortly it is denoted with EI and EJ. So for forward direction, for event 1, this is earliest starting time, this is earliest finishing time. And if you take event 2, this is earliest starting time, this is earliest finishing time. Similarly, all events, this is EI EJ. EI means earliest starting time. EJ means earliest finishing time. Similarly, for each and every individual event, this is starting, this is finishing. This is EI and EJ. EI and EJ. Similarly, last, this is EI and EJ. Here, this is forward direction. Same, if you come with backward direction, then according to these event only, this is called latest starting time, this value. And this is latest finishing time. This is denoted with LI and LJ. So for event 7, if you come backward process, this is the latest starting time, this is the latest finishing time. Similarly, this is latest starting time for event 6, this is latest finishing time for event 6. Similarly, event 4, 5, 2, 3, 1 also. So this is LI, LJ. So if you come backward direction, these are the latest starting and finishing times. Okay. So notations are EST. EST indicates earliest starting time. So for finishing this event from here to here or event to here, it will take the starting time like this. If it is some zero, every event, the starting time will begin with 0 onwards. 0. And let us take for same this with after notations, I will explain the one problem. EST indicates earliest starting time. And EFT. EFT indicates earliest finishing time. And LST means latest starting time. And LFT means latest finishing time. And these are the abbreviations for EST, EFT, LST left hand. These are denoted with EST denoted with EI, LST denoted with EJ, and latest starting time denoted with LI, latest finishing time denoted with LJ. And we have one more definition, one more notation, that is EIJ, sorry, DIJ or TIJ. Means it is the time duration for finishing that activity. It is the time for finishing the corresponding ith and jth event or activity from I to j activity. Next, here for same this example, if I give certain, if I take certain values here, same this diagram. Let us suppose this is, let us suppose the figure like this. Let us assume. So starting, this is 1, 2, 3, 4, 5, 6. Starting event is 1, ending event is 6. Now, for finishing this activity, I am taking the forward direction. For finishing this activity, yes, I am giving, this is 2 minutes. This is 3. This is some 1 minute. This is some 5 minutes, 6, and 7. Suppose this is 8. Let us assume. And by using this one, we have to find the shortest distance to finish this entire task. Means to start from 1 and end with 6. So how many routes we have? 1 to 2, 2 to 4, 4 to 6. And another route 1 to 3, 3 to 4, 4 to 6. And we have one more route 1 to 3, 3 to 5, 5 to 6. So by using all these route maps, we have to find the which is the shortest distance. With the help of that one, we can finish the entire task with short period of within short period of time. Before going to solve these type of problems, I want to explain some more definition, that is critical path. Okay, critical path, critical activity, critical node. Right. So let us take first critical path. So in this year, after indicating with the help of all the distances, we have to find the longest route first, which is the longest route. In that longest route, see for what kind of route it will give the maximum distance. That indicates the critical path. In that critical path, whatever the activities are touching or whatever the events are included, that activities are called critical activities. So in that longest path, what kind of path is existing? That path is called critical path. And in that critical path, what type of or what kind of events are included? That events are called critical events. See, I'll show it. So suppose this is the what about route maps? First, we have to find the critical paths. So first, starting 1, 1 to 2, 2 to 4, 4 to 6. This is one route map. So what is time duration? This is 2, 3, 6. So what about total distance? 9, 11 hours. Whatever it may be, hours or minutes. And this is another route. 1 to 2, sorry, 1 to 3, 3 to 4, 4 to 6. So what is time duration? 1 minute, 5 minutes, and 6 minutes. So totally it is 12 hours. Next, we have one more route. 1 to 3, 3 to 5, 5 to 6. What is the duration? 1, 7, 8. 8 to the 16, 16 hours. So in this, which is the longest path? This is the longest path. So indicate with double arrow marks. Okay, longest path. So indicate with the double arrow mark. This is the critical path. In this critical path, whatever the activities included, that activities are called critical activities. So here, this activity, if you give with the names, this is A, B, C, D, E, F, G. So in this, totally G events are G activities are there. Among this, only B, E, G, B, E, G are the included in this critical path. So B, E, G are called critical activities. And in these critical activities, how many nodes are touching? 1, 3, 5, 6. These are called critical events. Is it clear? They are the critical events. And this longest path is called critical path. Right? I'll show in one diagram. Right? Just wait, I will share the screen. See, so some more definitions on critical path. Critical event means the critical event. So since the slack of an event is difference between the latest and earliest event times, that is Li minus Ei is called critical event. That is latest starting time and earliest starting time. The difference between these two is called this event with zero slack called critical event. So if we take Li minus Ei equal to 0, then that is called critical event. And a critical activity means since the difference between the latest start time and earliest start time of an activity is called total float, and the activity which with zero total float are called critical activity. So the total float value equal to 0, then that is known as critical activity. Next, critical path. The longest distance in that entire diagram is called critical path. Okay. Next. Here. Next. Before going to start the problems, we have two more methods. That is, one is forward pass computation and backward pass computation. So if you move in forward direction, what about the rules and regulations we are going to frame for uh, completing the task? Similarly, if you use a backward pass process, what about the rules and regulations for calculating that entire critical path distance and critical events values? Okay. So first, let me discuss forward pass process. Here, this is forward pass computation for earliest event times. So in this here, before starting the computation, the occurrence time of initial network events is fixed. Then the forward pass computation yields the earliest start and earliest finishing times for each activity INJ, and indirectly the earliest expected occurrence time for each event. This mainly done in three major steps. So for calculating the each and every individual events earliest starting time, earliest finishing time in forward direction, we have to use these three steps. First, step one, the computations begin from the start node and move towards the end node. For easiness, or in another way, simply we can write in forward pass computation start by assuming the earliest occurrence time of the zero for the initial project event. It means for every starting event, we have to begin with zero time duration. So that is known as begin from the start node and move towards the end node. For easiest, the forward pass computation start by assuming the earliest occurrence time of 0 for the initial event or initial project event. Step 2. And earliest starting time of any activity is the earliest event time of the tail and event, that is ES. The earliest starting time equal to, simply we can denote with EI. So here I given the notation also here. In forward direction, yes, this is the event, and the first quantity in rectangular box, the first quantity indicates EI, that is earliest starting time. EJ indicates earliest finishing time. So we have formulas for calculating the finishing time and starting time. Earliest finishing time activity will be that activity to total distance. So add starting time with total duration. That is earliest finishing time equal to earliest starting time plus Dij. Dij or Tij. Dij indicates the time duration for finishing that activity. Similarly, next, earliest event time for event J is the maximum of the earliest finishing time of all activities ending into the event, that event, that is Ej equal to maximum of. So if the junction is occurred, so if you want to move, if you want to reach some event, let us suppose event D, but if it is two directions are there, A to D is there and B to D is there. Among these two, we have to take the maximum distance. Which is the maximum distance? That distance can be assigned to the earliest starting time for event D. So earliest finishing time, sorry, earliest event time for each J is the maximum of the earliest finish time for all activities ending into the that particular event. That is Ej equal to maximum of earliest finishing time for all immediate predecessors of Ij, or Ej equal to maximum of Ej plus Dij. And the last step, and computed E values are put over the respective circles representation each event. So after calculating this EI, EJ, indicate that values EI, EJ in that corresponding event. This is forward pass process. And coming to the backward pass process, here, this is backward process. So while going to compute all latest available times, means latest finishing time, latest starting time, we have to use the following procedure, or we have to apply the following four major steps. The latest events L indicates the time by which all activities entering into that event must be completed without delaying the completion of the project. This can be computed by reversing the method of calculation used for earliest event times. This is done in the following four steps. So first, before that, just see the notation. See here, if you use the backward direction, so the take one rectangular box on that circle and take divide into two parts. First part indicates LST, latest starting time. It is denoted with LI. And second rectangular box, that is LFT, latest finishing time, that is denoted with LJ. So these are the backward directions. So coming to the first step, for ending event, assume E equal to L. And remember that all E's have been computed for forward pass and computations. So after computing the all forward process values EST, EFT, then coming to the LST, LFT. So the latest finish time for activity Ij is equal to the latest event time of event. That is LFT, latest finish time equal to LJ. So whatever the time is there for event LJ, that is finishing time, latest finishing time. Next, step 3, latest starting time of activity Ij equal to the latest completion time of Ij minus the activity time. So Lj minus Dij. So the starting time will be, it is reverse order. So If you want to move from 1 to 2, how much time is there? 2 minutes. If you assume 2 minutes is there, so we have to subtract the 2 from total activity finishing time. So LJ, finishing time minus activity time duration, that is DAJ. Next, last step, the latest event time for event is the minimum of the latest start time of all activities organizing from that event. It means whenever if you come backward direction, junction is occurred. So that is, if you reach A, we have two directions. Let us suppose we have D to B, B to A, and D to C, C to A, reverse order. So for D to A, if you want to reach D to A, let us suppose we have two directions. One direction is D to B and B to A, and another direction is D to C, C to A. In these reverse two directions, see which is the minimum latest starting time. So we have to indicate that latest starting time is the best time for reverse order. Whenever it is junction is occurred. So latest event time for event is I is the minimum of the latest start time of the activities organizing from that event, that is Li equal to minimum of latest starting time for all immediate successors of Ij, that is equal to minimum of latest finishing time minus time duration for that activity. So LFT minus D. So the computed L values are put over the respective circles represented in each event. This is the backward pause process. I'll show it here with one diagram. I will show it. It is 1 minute. I'll show it. See here, yes, if you take this figure, see here, I'm taking the diagram. Starting event is 1, and we have the ending event is, this is 9. So I want to move from 1 to 9, and for all these 1 to 9, we have total different possible paths are, we have totally 4 routes to start with 1 and end with 9. So what is the routes? 1 to 2, 2 to 5, 5 to 8, 8 to, and it is 8 to 9. Okay. Next, another route, 1 to 3, 3 to 7, 7 to 8, and 8 to 9. Similarly, another route we have 1 to 3, 3 to 4, 3 to 6, 6 to 9. And the last route 1 to 4, 4 to 6, 6 to 9. Among these 4 routes, we have to indicate first the total longest distance. So if you choose first one, 1 to 2, 2 to 5, that is activity 1 to 2, activity 2 to 5, activity 5 to 8, and activity 8 to 9. It has taken, the time is 2 minutes plus 4 plus 1 plus totally 16, 10 hours or 10 minutes, whatever it may be. Next 10 hours it is. And second route map, 1 to 3, activity from 1 to 3, 3 to 7, 7 to 8, 8 to 9. So 1 to 3, it has taken 2 hours, 3 to 5, 5 hours, 7 to 8, 4, and 8 to 9, 3 hours. Total duration is 14 hours. Similarly, we have 2 more routes. So another third one route is 1 to 3 activity, 3 to 6 activity, and 6 to 9 activity. So it has taken time duration is 2 plus 1 to 3, 2 hours, 3 to 6, 8 hours. Uh, sorry, 3 to 6 is 8 hours, and 6 to 9 is 5 hours. So total it is 2 plus 8 plus 5, 10 plus 5, 15 hours. Similarly, we have one more route from 1 to 4 and 4 to 6, 6 to 9. For finishing this activity, the time duration is 1 to 4, 1, 4 to 3, 3 hours, 6 to 5 is 5 hours. So total it has taken 9 hours duration period of time. Among these 4 route maps, which is the longest distance? 15 hours. That is 1 to 3, 3 to 6, and 6 to 9. Is it clear? 1 to 3, 3 to 6, 6 to 9. So this is the critical path. Why? Because this is taking the longest distance, 15 hours, to start with 1 and end with 9. It has taken totally 15 hours duration of times here. So indicate this critical path with double arrow mark. So among that 4 routes, I am indicated with the double arrow mark. 1 to 3, 3 to 6, 6 to 10. Why? Because this is the longest path. This path is called critical path. And whatever the events which are included in this path, they are called critical events. And whatever the activities which are included in this path, they are called critical activities. Now, after indicating this, coming to the yes, I want to find the latest starting times, latest finishing time in forward pass, and latest sorry, earliest starting time, earliest finishing time in forward direction, and latest finishing time, latest starting time in backward process. See here, how we are going to fill this. First, before going to fill all the LST, LFT, EST, EFT, we have to finish first critical root activity and events values. So in critical path, what about events? We have 1, 3, 6, 9. So first we have to fill the values for this root first. That is 1, 3, 6, 9. So first event 1, it has taken here. First start with 0 time duration. So EST I am putting first 0, and for finishing 1 to 3, coming to the 3. So totally it is traveling 2 hours time. Okay, 2 hours time is over. That's why I'm indicating for 3, first rectangular box value is 2. Why? Because from we have to come from 1 to 3, it has taken 2 hours period of time. Next, already 2 hours is completed. Next, we have to move from 3 to 6. So 3 to 6, it has taken 8 hours. but already 2 hours completed. So 8 plus 2, we have to write that is 10 hours. Okay. Next, 6 to last end 9. So 6 to 9, it has taken totally 10 hours, but 6 to 9, it has taken 5 hours period of time. So 10 plus 5, it is 15 hours. So in 9, actually the photo it is missed, it is in a circle 9, the first distance is 15. Okay, that is earliest starting time. Now we have to finish earliest finishing time with same values with subtracting 1 and 1 in reverse order. So 15, put 15 finishing time, and 15 minus 8, sorry, 15 minus 5, that is 10. 10 minus 8, 2. 2 minus 2, 0. So in critical path, see here, critical path, I will repeat once again. In critical path, the distance of Li and Ei must be 0. That is Li 0 and Ei 0. 0 minus 0, 0. Next here, third event here. Li is 2, Ei is 2. 2 minus 2, it is 0. So the in critical path events, the LST, EST must, the subtraction of LST minus EST must be 0. And with the help of this, now coming to the remaining, the events which are not included in critical path, we have to fill that value. Okay, so here first 2, event 2, starting with 0, event 1, I want to move from 1 to 2. So it has taken 2 hours period of time. So for event 2, the starting time will be 2. Next, 2 to 5. 2 to 5, already 2 hours is completed. So 2 plus 4, it is 6. So for event 5, the earliest starting time will be 5 hours. Sorry, 6 hours. 2 plus 4, 6. Next, 5 to 8. 5 to 8, see here, for reaching 8, we have two different routes. This is junction box. So for filling these, don't take directly 6 plus 1, 7. We have to calculate what about total duration for finishing these activity, or for moving from 1 to 8, how many routes are there? We have to take the longest distance. I already explained the forward pass process just now. So in forward process, if junction boxes are there, we have to take the maximum quantity. So see here. So if you move in this way, that is uh, 1 to 2, 2 to 5, 5 to 8. It has taken totally 7 hours period of time. Similarly, we have another route map for 1 to moving from 1 to 8. That is 1 to 3, 3 to 7, 7 to 8. So in this way, what is the total duration? 1 to 3, 2 hours, 3 to 5, 5 hours, 7 to 8, 4 hours. So 2 plus 5 plus 4. So 7 plus 4, 11. So total it has taken 11 hours. So if you come from 1 to 8, we have two routes. First route is 1 to 2, 2 to 5, 5 to 8. In this direction, it has taken totally 7 hours period of time. And another route, 1 to 3, 3 to 7, 7 to 8. In this direction, it has taken totally 11 hours period of time. So among this, which is the maximum? 11 is the maximum. So we have to put 11 here. Is it clear? The 8th circle, the first earliest starting time will be 11. Why? Because two directions we have. Among these two directions, the maximum length is 11. So I am putting that 11 is the earliest starting time for this activity, this event 8. Next, 8 to, and don't fill this 9 because already it is finished 15, 15. Next, coming to the remaining activities. So the activity which is 7, coming to the 1 to 3, 3 to 5, 3 to 7. 3 to 7 means it is already 3, it has completed 2 hours duration time. If you come 3 to 7, extra we need to spend 6 hours. So 2 plus 5, 7 hours. So this is 7 is the, for 7 event, 7 is the earliest starting time. Next, first we have to fill all earliest starting time, then backward process we can finish the latest finishing times or latest starting time. Next, 4 here. 4 is also the box, the event which is not comes under the critical event. So we have to fill that one. 1 to 4, 0 plus 1, it is 1 hour. Next, all we finished this, and coming to the latest finishing times. unless or latest starting time. For filling that second square box, we have to come in a reverse direction. That is 9 2. See here, 9 already it has 15 15. So if you move 9 to it reverse process, it has taken 3 hours. Means we have to subtract that 3 hours from 15. So 15 minus 3, that is 12 hours. Next, coming to the 5. 8 to 5 reverse order. So already 12 hours is completed. 12 minus 1. I am filling the reverse order first circle, first rectangular box value. So 12 minus 1, that is 11. Next, 5 to 2, that is 11 minus 4, 7. Okay. Next, similarly, 7 to, if you come with 7 to, next, 7 to already 3 is completed. Next, 4 is there, event 4. So, sixth event latest time is 10 hours, and 10 minus 3, that is 7. So, it has taken latest time for event 4 is 7. So, with this, we finished all activities, earliest starting time and earliest finishing times. Okay, EST, EFT, and LST, LFT. Okay, with help of this, we can find all starting time and finishing time for each and every individual events. Okay, so once again repeat, the critical path is denoted with the double arrow marks. First, we have to fill that values, earliest starting time, earliest finishing time, and remaining quantity. The events which are not included in critical path, that is 2, 5, 8, 4. So 2, 5, 8, 7, and 4. So we are going to fill this with forward process and backward process. Okay. So these are the uh, calculating the critical path and calculating the earliest starting times and earliest finishing time and earliest starting time and latest starting time and latest finishing times. Okay. So in forward process, we are using earliest starting time, earliest finishing time. In a backward process, we are filling latest starting time and latest finishing times. Okay. And in this year, whenever the junctions are given in forward process, among that all distances, we are picking the maximum distance. If you come in backward process, if junctions are there, in for filling that quantity, we are taking the minimum of all that distances in a backward process. Okay? With this rules, with this procedure, we have to find the critical path and critical activities and critical events and whatever the latest time or earliest time, latest finishing time, latest starting time, and earliest starting time and earliest finishing time. Okay. So these are the activities which I covered. These are the some major topics in a critical path. Okay. In next class, we will going to discuss PERT, PERT, Programming Evaluation Review Technique. Okay. Okay. Let us start. Let us continue next class.